Welcome back to Bits and Bytes. This is part one in a two-part series where we're focusing on the different types of data that you're going to come across in Python. In part one of this series, we're going to look at more basic data types, things like integers, strings, floats, booleans. Next week's video, part two, is going to focus on more complex data types. We're going to look at things like sets, tuples, and dictionaries. With all of my videos, I do post the link to the Google Colab notebook in the description. So go on ahead, grab that link right now and download the notebook so you can follow along and get the most out of this exercise. If there's any future content that you'd like, or if you have any questions, go ahead and drop them in the comments. And if you appreciate the content, don't forget to like and subscribe. All right, so let's talk about data, specifically the types of data that you're going to come across in Python. And I know, this is not sexy, it's not fun, but it's kind of fundamental information that you need to know in order to be an effective developer, coder, programmer, analyst in Python. In fact, you could actually get by for quite a while, but you're going to hit a point in the road where your code's not working and you can't debug it because you don't understand the data and how it's working and how you're supposed to be working with it. So basic data types in Python, basically these are Booleans, integers and floats, and strings. Now technically integers and floats are two separate distinct data types, but I have them categorized together here as one group simply because they're numbers and that's easy to understand. And so what are Booleans? They are true and false values, logical values, basically always represented as true or false. You can think of it as like a binary value, 1 or 0, but true or false. So if we expand this, if we type true with a capital T, Python echoes back true. If we type false with a capital F, Python echoes back false. If we type false with a lowercase f, we get an error. We get an error because Python is case sensitive. Especially when it comes to Booleans, it's important that that first letter is capitalized. So this command here, type, basically will tell you the type of data that you're working with. This is important because if you have a data frame or a data set or a massive array or basically a lot of data and you need to just quickly find out what type of data a specific variable is, you can use type and it'll tell you. So if we do type true, Python returns bool. If we do type true in single quotations, we'll see that Python tells us it's a string. So strings are represented with single or double quotes. Booleans, on the other hand, do not have quotes. So, Boolean. Same for false. Type false, Boolean. So, all right, why are Booleans important? So, Booleans are important because they're the foundation or the building block for comparing variables or comparing data in Python. And so, why is it important to compare data? It's important to compare data because that's how you set conditions. So, if this condition is met, then I want Python to do this. If this condition is not met, then I want Python to do something else. And all of that resolves to, for the most part, Booleans. And so it's important to understand what Booleans are and how you can use them to compare data. So very simplistically here, we're assigning x to the value of 10, we're assigning y to the value of 15, and then using double equal signs, we're saying does x equal y? False. X does not equal y. We would expect that. Alternatively, we can use the exclamation point with an equal sign, and the exclamation point in Python represents not. So does x not equal y? We would expect that to be true. X is 10, y is 15. X does not equal y. Alternatively, we can do greater than, less than, and greater than or less than equal operators. So is x greater than 10? False. X is not greater than 10. Is x less than or equal to 10? True. X is less than or equal to 10. This next example, basically what we're doing here, and I know that we haven't talked about importing packages or libraries. We haven't talked about NumPy. Don't worry about that. You don't necessarily have to worry about what's going on up here, although the code is pretty simple. Basically, all I'm doing here is I'm generating 50 random numbers, and I'm assigning it to the array x. And then here, I'm generating 50 different random numbers, and assigning it to the variable y, or the array y. And then right here, I'm saying, is the mean or the average value of all of those numbers in x greater than the average value of all of those numbers in y? False. Okay, why is that important? Well, let's use a business example. Let's say x represents product x and y represents product y. And these values, instead of them being random numbers, they are the amount of profit that we get each time we sell unit x. And this is the profit that we get each time we sell the unit y. And we want to know, is the average profit for product x greater than the average profit of product y? And we can see that in this example, it's not. So how would you use that? Well, you would use that to maybe market to customers a certain way. So let's say you're a customer and you've bought product X, and the company knows that because it's tied to your account. So you've bought product X, but you haven't bought product Y. And product Y generates more profit than product X. You could write a program that says, well, since the profit for product X is not greater than the profit of product Y, and you've bought product X, we're going to market to you specifically. We're going to send you a text message. We're going to send you an Instagram push notification. We're going to do something from a marketing perspective that markets product Y to you because it generates more profit. So you can use it in a sense to create programs based off of conditions being met or not met. And that's basically what I'm giving you as an example here. So we assigned x and y as arrays before. Just for the simplicity of this exercise, I'm defaulting them back to single variables. And we're saying if x is greater than y, then print x is greater than y. Else, print x is not greater than y. Let's run that code. X is not greater than y. We would expect that. So with Booleans and all of our data types in Python, we can convert them to other types of data. And so in this case, I'm creating a string. That string is hello world, and I'm assigning it to the variable x. Then if I do type, we'll see that x is a string. If we print x, we'll see that we're printing hello world, the string. Here, we're converting hello world to a Boolean. And actually, let me go on ahead. I'll just replace that with x. So we're going to take x, which right now is represented as hello world, and we're assigning it to, well, we're replacing it with a Boolean. And then we'll do type, and we'll see now it's a Boolean. We'll print x, x is true, because Booleans always resolve to true or false. Next section we want to talk about are integers and floats, and these are basically numbers, like I said before. So integers are whole numbers, floats are numbers with decimals. That's it. Pretty straightforward. Now, with all numbers, there are mathematical operations that you can perform. So you can do addition, you can do subtraction, you can do multiplication and division, and you can also do integer division. Integer division in this case is denoted by 2 backslashes, and we're dividing 10 by 3, and the resulting output is 3, simply because 10 divided by 3 is actually 3.3 repeating. However, since it's integer division, it only outputs the 3. We can raise values to the power. In this case, we're squaring x. That's denoted by the double asterisk. And then we can do modulus, also known as remainder division. As you recall, x is equal to 5, and we're taking 5 mod 2, and the result is 1. Wait, what? How does that happen? Well, this basically outputs the remainder of any division that you do. So 5 divided by 2 is 2 with the remainder of 1. So 2 times 2 is 4, remainder of 1 gets us to 5. All right, so modulus division always outputs the remainder. It might not be apparent right now why modulus division or integer division is important, but as you progress in your software development or programming, you'll understand the functionality a little bit better. You can do some really creative things with integer division and modulus division. The last category we're going to talk about today is strings. And so strings basically they can be a word or number, but it's represented as basically a character, a letter, so to speak. So if we take, here, let's actually do this. There we go. So X is a string, and type X tells us that it's a string. Now, this is technically a number, but because it's in quotes, we're assigning it as a string, and we can see type X equals string. Alternatively, if we assign X equals to 5, which is an integer, and we do type 5, or type X, we'll see that it's an integer. Okay? So with strings, one of the most important things to know when it comes to handling strings is how to concatenate them. So strings are basically letters or characters, and you can't add letters, you can't add characters. So hello plus world, it doesn't equal like a mathematical result. So with concatenation, that's basically combining strings. It's taking hello and it's combining it with world. Actually, let's get rid of this for now. So if we execute that, we'll see that hello and world are smushed together. If we add in the space, it prints hello world. So we're taking the string hello and we're adding it to the string world with a space in the middle. And the result is hello world. So why do you need to know how to concatenate strings? Well, this is very helpful when it comes to data management, data, just cleaning, data wrangling, just handling your data. Concatenating strings is a very useful thing to know how to do, or even just be aware of. So let's say you have a database, and in that database there's a table, and that table represents all of the addresses for your customers. That table is typically going to be populated with individual fields or variables for street, city, state, and zip code. Well, what if you wanted to print shipping labels for all of your customers? It would be helpful if all of these fields were combined into one variable called address. And you do all of the formatting here in your code, and then when you print address, you have the actual address for the customer versus having to print 4 separate variables each time you want to generate a shipping label. Just like with Booleans, we can convert strings. So right now X is a string, and yeah, X is the string 5. So right now X is a string, and we want to make X an integer. All you have to do is use integer with parentheses and reassign it to X, and we do type X, and we see it's an integer. Now, what if we make X equal to the string 5.01, and then we try to convert that to an integer? We can't do it. Why can't we do it? Well, we can't do it because 5.01, even as a number, cannot be an integer. An integer, remember, is whole numbers. So we have to convert X to a float. And if we do that, we'll see X equals 5.01. Type X is a float. Thank you for tuning in. We just wrapped up our episode where we discussed the different types of data that you're going to come across in Python. Next week, we're going to be releasing the video part 2 in this series, more complex data types. We'll cover things like dictionaries and sets and tuples, when to use them, what are their use cases, why they are important. If you enjoy the content, please like and subscribe. Thanks again for watching. This is Bits and Bytes, where we provide you with bits of analytics content in bite-sized chunks.